Hello everyone, today we're looking at the topic of tree diagrams and finding the probabilities of successive events. We're going to look at a few different examples. We're going to start with a scenario we have in front of us where we have a bag with 7 counters in them. Now 5 of them are red and 2 are green. We're going to look at trying to find the probability when you take out a counter, see what color it is, put it back in, and then take it back out again. And we're going to see what the probability of these different scenarios will give us. Now, there are a few ways in which you can do this, and as we've seen in previous videos, that we could create a sample space diagram or a possibility space diagram, which I've done over here. Now, as you can see over here, we have our first pick over here, which is 5 potential reds and 2 greens. Or we've got our second pick, which is 5 potential reds and 2 greens. And the probability of getting 2 reds are in this box over here. And the probability of getting 2 greens are in this box over here. Now the probability of getting 1 red and only 1 red is this box and this box over here. And if we count these up, now in total we've got a 7 by 7 grid here, which means that there are 49 possible combinations. The probability of getting 2 reds is very simply just the red box, which we can see is 5 by 5, which is 25 out of 49. Now, the probability of getting 2 greens is the grid in the bottom right-hand corner, which is very simply just 4 out of 49. And then the probability of getting 1 red in this case would be 2 by 5, which is 10 plus 10. So 10 out of 29 plus 10 out of 29, which is 20 out of 29. So those are our probabilities done by a sample space diagram. Now this took me quite a while to do. It's not a very, very quick method. You can do it, but there is an easier way in which we can do this. And the way we show you this is via this method of a tree diagram. Now a tree diagram gives us effectively what we call a tree, where we start at one point and we draw pathways in which you can go. Now the pathways which we can take over here is, I'm going to look at my first pick. We've got my first event, which could either be a red or a green. This is my first pick. This is event number 1. Now, the probability of getting a red, we said in my first pick, is 5 out of 7. The probability of getting a red on or a green on my first pick is 2 out of 7. 2 out of 7. Now, that's my first pick. Now, if we take that out and we put it back in again, my second pick is going to give me the exact same probability. We're going to get either a red or a green, and either a red or a green. Now this way, if I follow this branch, it means I've got a red first, and then I get a red again, or a red first, then a green. Now we said the probability in this scenario of getting a red again is 5 out of 7, and for green it is 2 out of 7. So this probability over here, once again, is 2 out of 7. Just use a different color for that. So 2 out of 7 for that. Now the probability of getting a green, we said, is 2 out of 7, and red again is still 5 out of 7. And the probability of getting a green is still 2 out of 7. Now, if we look at our sample space diagram, we said the probability of getting 2 reds is 25 out of 49. Now that would be following this branch and then this branch again. Now you might be able to see that actually if you multiply 5/7 by 5/7, you get 25 out of 49. And this is how tree diagrams work. You multiply successive probabilities along your branch to work out your final probability. So 5/7 times 5/7 is 25 out of 49. That's the probability of getting 2 reds. The probability of getting a red then a green is 5/7 times by 2/7, because 5/7 then 2/7 is 10 out of 49, and that represents this little box over here. The probability of getting a green then a red are these 10, which is 2/7 times by 5/7, which is 10 out of 49. And then finally, the probability of getting 2 greens, we can see in this corner over here, is 2/7 times 2/7, which is equal to 4 out of 49. So we can see that when you are doing tree diagrams, you multiply across your branches to work out the successive probabilities. So you multiply across. What you also might notice is that on each specific tree, all the probabilities add up to 1, because that refers to all the possibilities you can get. In a bag, you can either get red or green, so that adds up to 1. 5/7 plus 2/7 makes 1. 5/7 plus 2/7 makes 1. 5/7 plus 2/7 makes 1. And over here, the final scenario you can either get red or red, red green, green red, or green green. 25, 10, 10, and 4 add up to 49 out of 49, which also gives us a probability equal to 1. Now, this was when we looked at a scenario where you take one out, you put it back, and you take another one out. Probability of getting 2 reds was 25 out of 49, red then red. Probability of getting 2 greens was green then green, 4 out of 49, as we saw over here. And then the probability of getting 1 red could either be red and green, which is 10 out of 49, or green and red, which is also 10 out of 49, which collectively made our 20 out of 49. So when we look at this scenario, if I change this, if I tweak this question just a touch, something which is very common to see in questions is if you take one out, you don't put it back, and you take another one out. So if I take out one ball or one counter, and then I don't take it out. Now my first pick will still be the same. I've still got all of these in there to work with. But my second pick will change. If I take out a red counter first, I now have one less red counter in there. That means the probability of getting a red now is only 4 red counters out of a total of 6. So this becomes 4 out of 6. And the probability of getting a green is 2 out of 6. This is what we call conditional probability, where the first situation determines the second. So that was getting a red first, and then we have those values over there. Now, in the same way, if I picked a green one first, so I still had my 5 reds, the probability of getting a green at this moment is still 2 out of 7. But if I take away one of these green ones over here, I'm now left with 5 reds out of 6, and then 1 green out of 6 afterwards. The probabilities on the second branches have changed, which means when we do our multiplication, these values over here are all going to change. So all of these values have now changed. And if we multiply across, it's no longer 5/7 times by 5/7. It's now 5/7 multiplied by 4 out of 6, which is 20 out of 42. The probability of getting red then green is 5/7 times by 2 out of 6, which is 10 out of 42. This is 2/7 times by 5/6, which is also 10 out of 42. And then finally, 2/7 times by 1/6, which is equal to 2 out of 42. So now the probability of getting 2 reds has dropped to 20 out of 42. The probability of getting a red then a green is 10 out of 42, and a green then a red is also 10 out of 42. So the probability of getting 1 red is 20 out of 42, and the probability of getting 2 greens is 2 out of 42. So just be very, very careful when you are reading the question in this case. Now we look at one last example. We're going to build on this just a little bit, and just to see that tree diagrams aren't always used for taking counters out or eating sweets. Sometimes it could just be looking at different scenarios or different probabilities that are occurring together. So over here, what we have is a question where we can see two people that are late for school. So it tells us that the probability that Alia is late for school is 0.1 and the probability that Tim is late for school is 0.25. Find the probability that neither are late, find the probability that one is late. Now, in our last question, we had two events. Our first event was our first pick, our second event was our second pick. This time, the events are that each person is late. We can first have Alia. Is Alia late or is she not late? Is she on time? So I'm going to have this as late and not late. The probability that Alia is late is 0.1, which means the probability she's not late is 0.9. In the same way, we need to apply this for Tim as well. So the first event is whether Alia is late. The second event is whether Tim is late. And the probability Tim is late is 0.25. So if I have my late and not late, late and not late, because we said if Alia is late, then Tim is 0.25 and 0.75. If Alia is not late, Tim being late is still 0.25 and Alia not being late is 0.75. And we simply just apply the same process we did previously when working out probabilities. To work out the probability that both of them are late, we go Alia is late, Tim is late, we multiply 0.1 times by 0.25, which gives us 0.025. So that's the probability that they are both late. The probability that only Alia is late is 0.1 times by 0.75. 0.1 times by 0.75, which is equal to 0.075. The probability that Alia is not late, but Tim is late is 0.9 times by 0.25. 0.9 times by 0.25 is equal to 0.225. And then finally, the probability that neither of them is late is 0.9 times by 0.75, which is equal to 0.675. So those are our different scenarios for these questions. So now the questions which we need to ask is find the probability that neither person is late. Is simply Alia not late, Tim not late, 0.675. The probability that one of them is late is going to be these two middle ones, because this is when Alia is late but Tim isn't. This is when Alia is not late but Tim is. It's going to be 0.075 plus 0.225, which is equal to 0.3. The probability that only one of them is late is 0.3. Now, just to finish this off, the very, very last thing I want to say is if we imagine another person had joined this question and said that one more person was late for school. So let's say, for example, Phil was late for school and his probability is 0.2. Find the probability that all three of them are late. Well, we'd go Alia is late, Tim is late, and then we draw another tree over here for late and not late. So this is our third event. And the probability of Phil would be 0.2 for late and 0.8 for late. So the probability that all of these people are late is 0.1 times 0.25 times 0.2, which gives us a value of 1/2000. Anyway, that is effectively how this works. When you work out probabilities, you multiply along. Thank you very much for watching. Take care and goodbye.